All right, let's continue on with another lecture on variation. So this word variation is probably unfamiliar to most of you, but let's go ahead and just start right off by defining it. So a very loose definition of the word variation in the mathematical sense is that it's just another way of saying the words related to. So if I say variation, you're just talking about two things that are related, two variables likely. And so if I say that one variable varies with another, for example, I might say x varies with y, because those are two variables, x and y, or at least I should say letters that we tend to use for variables. So if I say x varies with y, then I'm saying that the value of x and the value of y they're just connected in some way, in some mathematical way. So let's get into two different types of variation, and we'll see examples of exactly what I'm talking about when I say that these variables are connected, that they're related to each other. So one type of way that variables can vary with each other, that they can have variation, we'll call it direct variation, and then you'd say that these two variables vary directly with each other. And so so as if I have y equals kx, those variables are clearly related to each other. So x is, some variable, and then if I multiply it by this constant k, I'll go ahead and make a note of that k is constant. That's just a number it's just a placeholder for any number that it might end up being. So x multiplied by this number k ends up giving me y, which is my other variable. And so these are related, right? I might, we could come up with some examples of this. Let's say that x is my age, right? Well, as my age increases, my height would also follow with that, right? As you get older, you tend to get taller, obviously, up until a certain point when maybe you stop growing or something like that. But for a lot of your life, as you grow older, your height increases with you. And so the point here is just saying that my height is related to my age. You might be able to come up with a function with a relationship between your height and your age. And if we were to do that, we might say, hey, these things vary directly with each other. And then just another example, you could say studying is a variable x and your grade is a variable y. Well, those things are related with each other, right? They're two variables that can change, but your grade in the course definitely depends on how much you study. And presumably, the more that you study, the higher your grade would be. Last example here, the length of maybe a lecture that I'm giving you might be related to how bored you get, right? So if I say, if I lecture for a really, really long time, you're going to be very, very bored. If my lecture is pretty short, you might stay interested and you might not ever really get bored. So one thing that we'll notice here with these examples is that all of these, I'm using this sense of increasing, if you will. So, and what I mean by that is that as this variable x gets bigger, so does y. And we'll see actually the opposite of that in just a second, where in the opposite sense, if x gets bigger, y gets smaller. But here, we're seeing this increase that as I get older, my height gets larger. As I study more, my grades increase. As my lecture gets longer, your boredom increases as well. And so we're seeing this idea that the variable y is related to x in the sense that as x goes up, so does y. And then presumably as x goes down, so does y. If my age were to decrease, my height would also decrease. If my amount of time that I study decreased, theoretically, my grades would decrease as well. And so that right there is what we call varying directly, otherwise known as direct variation. It's when one variable increases, so does the other. So let's look at the opposite of this. And this is going to be inverse variation. We'll say that these two variables vary indirectly. And so this is saying that as x increases, y would decrease, or vice versa. As x decreases, y would increase. So let's look at two examples here. If I have a variable x, I'm going to call it driving speed. So that's the speed that I drive my car. And then variable y is the time that it takes for me to get to wherever I'm going. Clearly, those are related, right? The faster or slower that you drive, that's going to change the amount of time it takes for you to get there. But let's look at this carefully. If I increase my speed, that's going to decrease the time it takes to get to my destination. And so that's exactly what we're seeing here. Whereas x increases, y decreases. Right? As my speed increases, my time decreases, and vice versa as well. As my speed decreases, my time would increase. Let's look again at variable x being the distance away from someone and the volume of the sound that you might hear from them. So if you increase your distance that you're away from someone, that's going to decrease their volume that you hear them at. The further you are from that sound, the quieter it will be, and vice versa as well. So these are examples of varying indirectly. We'll call this inverse variation, and this is our formula right there, that y equals k over x. So just as a recap on these two types of varying. So we have variation. Let's go ahead and put that in a big box up here. So we've got variation, and the two main types that we have are direct and indirect. And equation-wise, they're going to look like this. And there we go. So we've got direct and indirect variation. Remember these equations, we're going to be dealing with these quite a bit. So now I've been using this word varies directly or varies indirectly or varies inversely like quite a bit. I want to talk about some other common wordings that you might see when someone's talking about direct variation. So if I am looking at the equation y equals kx, right? I'm looking at direct variation in that sense, that as x increases, so does y. If I'm looking at that, then I'm going to have y equals kx. And there are two main ways that you could say this. There are obviously others, but there are two primary ways that we'll talk about this. And if I say y varies directly with x, that's me talking about direct variation in this y equals kx equation. I could alternatively say that y is proportional to x. And that word proportional is the same meaning as varies directly, just another way of saying it. When I say proportional to, that's talking about direct variation. I could also have inverse variation, and we've seen actually a couple different ways. Let me include one other way that we saw before. Y varies indirectly with x, and that's that first way that we saw. But there's two other ways. We could say that y varies inversely with x, so we could just change that word inversely with indirectly. We could also say that y is inversely proportional to x, and if y is inversely proportional to x, then again, that's just that same exact meaning for inverse variation. It's just another way of looking at that. Great. So some common wordings there. Be very careful too. If I switch the order of x and y, that will change this equation that I deal with. If I said that x varies directly with y, that would correspond to x equals ky. So a slightly different equation there. So be careful on the order in which you say these. One thing I want to talk about looking at inverse variation here is just another way of looking at this, different from how we saw before. So let's say that we start off with y equals kx, just like we always would with inverse variation. But let's say that I set k equal to 20. All right. So just to give it a number here. If k is equal to 20, now what I can do is I can actually multiply both sides of this equation by x. And if I do that, I'm going to end up with x times y equals 20. So that's just me taking this and just multiplying by x on both sides. And if I have that xy equals 20, what that's saying is whatever my two variables x and y are, that's going to be equal to 20. So let's take a look at this. I've got a bunch of values for x and a bunch of values for y. And what you'll notice here is that no matter what I've written here, they all multiply out to 20. I've shown all that work right here. We get 20 every time. But take a look at this. As x moves from 1 to 2, y moves from 20 to 10. And that's a big jump in y for such a small jump in x. But what you're seeing here is that when x doubles, y gets cut in half. Take a look here. X doubles from 2 to 4, and y gets cut in half from 10 to 5. And as we keep going down, hey, x doubles from 10 to 20, and y gets cut in half from 2 to 1. Here, I'm seeing a huge jump in x, and I'm seeing a small jump in y. And so what a lot of people think with inverse variation is that inverse variation is almost just like a line that's sloped negatively. And that's actually not the case. So let's go ahead and graph this really quick. We'll get more into graphing a little bit later, but I'll just graph these right now really quickly for us. If I have y equals kx and y equals k over x. So if I graph this right here, each of these, x, y equals k, or let's just label that y and x. If I graph this line y equals kx, that's just going to be a line with a slope of k. So m equals k. Well, you'd like to use m for slope. If I graph y equals k over x, it looks like this. And this is not necessarily intuitive, but this graph over here follows this exact sort of idea of x and y that we're seeing right here. When x doubles, y gets cut in half. So let's take a look at that. If I let my x go from here to here, I'll use some different color. If I let my x go from 1 to 2, what you'll notice here is that my y is going from 20, and now it gets cut a lot, maybe all the way down to 10, for example, in the example that we used before. And so it doesn't really take a huge change in x to get a really big change in y with this inverse variation. But just to be clear, it's not a line with a negative slope. It actually has some curve to it. So just pointing that out there. Just as I've said before, we use k as a letter to denote a constant, but we actually have a special term for k, a special phrase that we like to use, and we call it a constant of proportionality. And it defines how connected the variables x and y are. And when I say how connected, I just mean how strongly connected they are. So let's for example use some direct variation, and let's put this in a word problem to take a look at this. So let's say that you make $50 every day when you work. The amount that you make in a month depends on the number of days that you work. So what I can do is I can give these I can give these things variable names. I can give these variables names, I should say. I'm going to call this x that I've underlined in blue. It's the number of days that I work. I've got that right there. I'm going to call y the amount that I make in a month. Y is the total amount of money that I make in a month. And so clearly these are related. I mean, obviously, I've said that above. The amount that you make in a month depends on how many days you work, because the more days you work, the more money you would make. So we would recognize that these variables are directly proportional to each other. They vary directly, because as I increase the number of days that I work, x, I'm going to increase the amount of money that I make y. And actually how this constant k comes in, this constant of proportionality, is exactly this. It's this $50 per day that I see. So this $50 per day ends up being that constant K right there. And so clearly, as X increases, I just take whatever it is and Y, I multiply it by 50 and I get Y. So as X gets bigger, so does Y. But now let's say this. What if all of a sudden I make $57 a day? So that amount increases, right? So you notice just the only differences on the slide is that I'm just changing from 50 to 57. Now, what you'd be able to say is that, well, as X changes from maybe 1 to 2, I'm going to make more money than I did before, because obviously I'm making more money per day. And so that's this idea that this constant of proportionality, in this case being 57, in this case being 50, as that constant of proportionality changes, so does that relationship between X and Y. It doesn't take me, the more days I work at $57 per day, I make a lot more money than I did at $50 a day. And so that constant K really does, it defines how connected they are, how, maybe we could add this in, how strongly connected those are.